Over the years, the Philippines has suffered from an inexhaustible number of deadly typhoons, earthquakes, volcano eruptions, and other natural disasters. In fact, the country has been one of the world's most disaster-prone. Because of this, there is a need to be proactive in identifying and preventing disasters to reduce risk. Roads and bridges are frequently damaged in the aftermath of a disaster. Although damages are inevitable, we can reduce this by knowing the condition of the infrastructure even before a disaster occurs. The current traditional method of inspection in high-rise infrastructures requires installation of scaffoldings before visual inspection of cracks and other damages is possible. This method is time-consuming, inefficient, and poses additional risks to the inspectors, especially in high-rise infrastructures. To answer this problem, the College of Engineering and Technology in MSU IIT proposes the adoption of unmanned aerial vehicles in infrastructure inspection.
So we are currently working on a research project that focuses on infrastructure inspection. The idea is to utilize the UAV's capability to reach high places and perform visual inspection. But the challenge with using conventional UAV is that there is a high chance of crash due to collision if you fly in a close proximity to walls or any narrow passages of an infrastructure like bridge. So the challenge here is to allow collision but will not result in a crash. We solve this by developing a protective shell around the UAV. This prevents the propeller from touching surfaces during operation, which may result in a crash. A gimbal mechanism is integrated to help stabilize the drone, especially during collision. A camera mounted on the UAV will then perform visual inspection during flight. We use deep learning to train a crack detection system that will aid inspectors to assess the severity of cracks and other damages.
With the help of DOST PCIEERD's funding, this research can provide a safer and more efficient inspection of infrastructures in the future. Its application can also be extended to disaster response, urban search and rescue operations, and disaster assessment. The future success of this project will pave a way for a new technology in the field of disaster preparedness and response in the country.